this. So this will be due on Wednesday. All right, number one. Feels like not that long ago. It's probably last week. This is a short chapter. Anybody want to start? I don't really remember where we're at.
Well, starting if you.
Okay. Luke, what kind of hush, hush. What kind of polynomial is number one?
Monomial.
A what?
Yeah, monomial.
Okay. How many terms does number one have? Two. The minus separates the two terms. It's x and minus 5. So that is a binomial. Does it list the options and the directions? Okay, this part, not all of us mastered. What is the degree on number one, Luke?
5.
No. Okay, the degree is the exponents of the term with the highest exponents. You add them all together.
What?
So x has an exponent of 1. So the degree is 1. Now the 5, technically you could say is 5 to the 1, but because it's not a variable, you don't count that exponent. Yeah.
So would the degree of number 2 be 0?
Yeah, what's the degree on number 2? 0, yeah. Okay, number... Yeah. Lauren, on number 4, a lot of us got the... Or, sorry, not 4. I probably should talk about 4, though. 3, how many terms does that have, Lauren? It does have 3. So that would be called a... Yep. Okay, and what is the degree? Not quite. So that first term has the highest degree. It's got x squared and y to the 1. So it's 3. All right, number 5 is plug stuff in. Oh, number 4. A lot of us missed this one on the homework. Does anybody remember what number 4, or think they know what number 4 should be?
Would it just be other corner?
Okay, not a polynomial. A lot of you got it wrong.
Oh.
There's like one of these on the evens. Why is it not a polynomial? If you're dividing by x or any variable, it doesn't count. So you just put not a polynomial. It's dividing by x because x to the negative 3 means there's x cubed in the denominator. So that's a no-no. So number 5, we're just plugging stuff in. Quite a few people missed these on the homework too. Even though it's just plugging stuff in. They were pretty large though. So there's a lot of places to make mistakes. So here's how you could plug in number 5. Just put 2 in for x, that's all I did. Okay, 2 cubed is 8 times 4. 32, 2 times 2, 5 times 0. So I saved the pluses and minuses for last, right? Because that's order of operations. 32 plus 4. Okay. Number 6 is one that, like it starts out as 8y to the 4th on number 6. But y is negative 1. Why, if you plug this in your calculator, would you get it wrong? Okay, because you have to take negative 1 to the 4th Order of operations would only do 1 to the 4th, and then they'd add on a negative, which is not what we want. We want -1, all of that to the 4th. Should come out as a positive 1, right? -1 times -1 times -1 times -1 should come out positive. If you don't put parentheses there, it'll spit out a negative. It's not because your calculator is wrong, it's because it's doing 1 to the 4th without the negative. But we're supposed to square all of y, so you would need that in parentheses. Now, when it's an odd exponent like the last time, it doesn't really matter because it's going to come out negative anyway if there's a negative right there. If it's already positive, it doesn't matter if you put parentheses because it'll stay positive either way. Right, that was number 6 actually, but that's not the answer. Number 7. 3x squared. 3 times 2 squared minus 5 times x times z. So this term, Davin, what would that be?
That would be 0.
0, so it kind of just goes away, times 0. And what would this term be?
Just 3 in parentheses, 2 second.
Okay. Yeah, in this case, parentheses don't matter because 2 squared is still going to be positive. So what would that be then?
It'll just be 3 times 2 squared.
Which is
3 times 4, which is 12.
right. 2 squared is 4. 3 times 4 is 12. 12 minus 0 is still 12. All right, number 9. Down to, this is what we've been doing this chapter, simplifying. So on number 9, it's an addition problem. We did addition, we did subtraction, we did multiplication, division. The rules change depending on what kind of problem we're doing. Alright, so when we're adding polynomials, James, what's kind of the rule for that? When you're adding polynomials, what do you do? Like if you're explaining what to do to somebody. How would you do that?
How would I solve?
Yeah.
I would just add 2x squared plus 7x squared.
Right, so it's called adding like terms, right? Adding the same kind. So 2x squared plus 7x squared is,
9x squared
yeah, notice the exponents do not change.
plus 3x
3x is by itself.
minus 15.
Minus 5 plus minus 9 minus 14.
So for 10, can you add the 2t plus the 6rt, or can you only, since there's an r, you can't do that?
What?
For number 10, can you not add the 2rt and 6rt?
There is no
I
2RT.
mean 2t and 6rt?
No, whatever T is, RT is something else. So no, cannot add those. It's kind of like saying, if you have a box of 20 pencils plus 2 more boxes of 20 pencils, that would equal 3 boxes of 20 pencils. But when you start changing the number of pencils, it's not going to equal 3 boxes of anything because they're all different. So anyway, you can only add like terms. They got to be the same. Okay. That's what works. 3b squared. This one is a subtraction. So this is one that a lot of us still get wrong sometimes. Okay, why do we get this one wrong a lot? not everybody, some of you got it down, but,
The two
'cause-
inside,
huh?
the two inside, the first one.
Oh, yeah, okay. That minus doesn't just apply to 6a squared, it applies to the parentheses, which means it applies to everything in the parentheses, like that. All right, so, how about this? Abby, I'll be the calculator, you just tell me what to do.
Take 5a and then minus it by negative 6a squared.
So 5a squared minus 6a squared be negative 1a squared, or just negative a squared. Those two.
And then take negative 8b minus 7a
Okay, you didn't say, huh?
positive.
Yeah, it's minus a minus. So remember when we have that, minus, that becomes a plus. So it's actually like minus 1 minus 7, it's like minus 1 plus 7. So that would be 6 AB.
And then negative 3b squared minus 10b squared.
Yes. Negative 3 minus 10. So it's like left 3, left 10, going backwards. So it's left 13, so it's minus 13b squared. Plus 12x squared plus y. Alright, did I copy that right? Yep. Okay. Alright, Atticus, what can we do on this one? Is there anything we can put this x squared with? What would add with that?
Yeah.
12x squared. So what's 1x squared plus 12x squared? 13x squared. Yeah, when you're adding and subtracting, the exponents don't change. Okay, how about the y squared? What we'll go with this?
The other two was for you?
Well, is this one a y squared? No, not that one. So, unless I copied it wrong. No, I got it. So, this one. So, do you know what that will be?
2y squared.
Not quite, because this one, we're actually subtracting both of these. So it's actually y squared minus y squared.
0.
So 0, it's just gone. You skip it. All right, and what have we not used yet?
The 10b squared.
No, I don't know what you're looking at. So we got a minus x and a plus y. Are those gonna mix? No. So we're just gonna put minus x plus y. Number 15. X minus 4. All right, Kenton, do you know what kind of problem this is? Distribute, yeah, which means multiply, yes. So, yeah, everything gets multiplied by 3x. So what's that first term gonna become?
4x. Or
multiply, so it's not 3 plus 1, it's 3 times 1.
Oh, 3x squared.
3x to the,
Third.
right, there's an invisible 1 on that x, so yeah, it's gonna be 1 more x than was, so x squared times x to the third, yeah. Okay, then the second term is gonna become,
-15x squared.
right,
And then 12x.
yep. It was, I think I might have said 9 and 10 were the hard ones, but I was not looking in the right spot. 19 and, well, maybe just 19 is the hard one. Oh, 18. It's like 19. Not that bad. Number 17. Negative 3a of 4b c squared. So they be the fifth. Alright. Takes me a long time to write it. Alright, Case, what's that gonna be?
Okay, so you would distribute the 3a to the fourth b c squared to the 2ab cubed, or 2a cubed b, and it would make it negative 6a to the 7th, b to the second, c to the second.
So we did negative 3 times 2 is negative 6. A4 times A3 is A to the 7th. B times B, B squared, B1 times B1. And then C squared is tacked on. Alright, next term.
3 times, negative 3 times 7 would be negative 21. A to the 5th, b to the 2nd, and c to the 7th.
Okay. Alright. So we're going out with a bang here. It's not that bad. Do you guys remember this lesson? It's probably like last Monday or something, I don't know. X squared minus 2x plus 4.
Lessons are called out Equal keys.
Alright, Brooke, any good ideas? It's not a division problem. What does it mean when parentheses are right next to each other? Multiply. It is a multiply problem. But how do we multiply those two large-ish things? Right? Yeah. This. Yep. So yeah, you're gonna do x times everything and 2 times everything. All 3 terms. So after we're done, we should have 6 terms. Well, and then we need to simplify it, but. Alright, so Brooke, what happens when I multiply all 3 of these by x? What is that going to give me? So x times x squared is what? Yep. Keep going.
Negative 2x squared.
Yeah. Yeah. Okay, so we're done with that x. We got multiplied. Now it's the 2. What's the 2 going to give me?
2x squared.
Yeah, and I'm going to put the 2x squared, it's positive, right under this x squared term. So later when I add them, they'll go, okay.
Negative 4x.
So now add the like terms, and the way I stacked it, they're kind of lined up. So negative 2x squared plus 2x squared, 0, 4x minus 4x, and then a plus 8. So that is all that remains. All right. That's kind of halfway point, so maybe we'll pause there.